Alright, we're going to cover the brainstem. Referring back to our picture, the brainstem is the fourth division that we're going to cover. The brainstem is going to include this entire thing where we see this sensory neuron traveling in. Motor neurons are also going to be traveling out. So we have motor, your primary motor cortex, which is here in your precentral gyri. This is where your motor is going to travel through and travel out through the brainstem. So when we talk about the brainstem, the major job of the brainstem is going to be for relaying sensory and motor neurons, but it also is going to use the brainstem to communicate with the cerebellum. But these represent the neurons, the information, the relay of information. Your motor neurons are going to descend through the brainstem from the precentral gyri down through the brainstem and out. Your sensory neurons are going to travel up through the brainstem and stop at the thalamus, which is part of the diencephalon. So when we talk about the brainstem, your brainstem has 4 different things that we're going to talk about. The first thing that we're going to talk about is the midbrain. The second thing that we're going to talk about is the pons. The third thing that we're going to talk about is the medulla oblongata. And the fourth thing that's located deep in the brainstem in all 3 sections is what we call reticular formation, also known as the reticular activating system, or simply RAS. So we are going to talk about the areas of the brainstem. Now, I always like to put things on pictures, and I'm running out of room really, so I'm going to use another lateral view, and I'm going to label my brainstem. All right, when we talk about the brainstem, when we divide it, the section that's underneath the diencephalon, right here, just going to highlight it, this is known as your midbrain. The section that is like really large and in the middle, that is known as your pons. And then the little section right here underneath the pons is known as your medulla oblongata. So there's 3 main regions of the brainstem when you divide it like this. Now, there are bodies of tiny gray matter that is located all throughout the brainstem and the midbrain, the pons, and the medulla oblongata. So you have this gray matter, and I'm just going to use a pencil. And then I'm going to highlight it. Throughout the midbrain, pons, and medulla oblongata, in all 3 regions, you have your reticular activating system. Or your reticular formation. RAS for reticular activating system. Now, these are tiny islands of gray matter. Scattered throughout the brainstem. Which we can see in this picture, your reticular activating system. Now, when we talk about the reticular activating system, basically, whenever sensory neurons travel through the brainstem, so sensory neurons travel up and they stop at the thalamus. Remember, this is going up. When sensory neurons travel through your reticular activating system, this is going to keep your reticular activating system on. Let me find my blue pen. Of course, I've lost it. All right, so I'm using blue. Oh, there it is. Sensory neurons are going to travel through the RAS, the reticular activating system. This is going to activate your cerebral cortex. This is when you're in a wakeful state. So, as your sensory neurons travel through the brainstem and stop at the thalamus, we talk about the reticular activating system. When it's on, by sensory neurons traveling through, you're alert, you're conscious. What I mean by conscious is I could ask you questions like, what day of the week is it? The next thing is, who's the president of the United States? What time is it? What chapter are we covering? Anything that you could answer. You're alert, you're awake, you're conscious. So it's turned on and activated when sensory neurons are traveling through, which is always happening when you're awake. So the RAS is activated when you're awake. I can ask you what day of the week it is. Now at night, you turn off the reticular activating system. So if I woke you up in the middle of the night and said, what are the 3 areas of the brainstem? You would be like, I don't know, because you turn it off. I could say, who's the president of the United States? You wouldn't know. So the RAS is turned off when you're asleep. You don't need it. You don't need to be thinking about it. So this one is going to be the area that helps you with your dreams as well. So whenever you're in your REM sleep, some sensory neurons are traveling through, so it's going to help you with your dreams. Now, if you damage this, if you damage the reticular activating system, you would go into a coma and you can never wake up. Let me put that in red. When you damage the RAS, you go into a coma and you cannot wake up. Now, it doesn't mean that you aren't going to have REM. Some REM happens when you're asleep. That's like whenever you start to hear your radio when you're sleeping and it starts to infiltrate your, or like it comes into your dreams. So, when we talk about the reticular activating system, these are just gray matter located in the midbrain, the pons, and the medulla oblongata. Now, it's important to understand the brainstem as a whole. So, when we talked about the brainstem and its function, when we originally talked about an overview, your brainstem is going to be a relay. We said it's going to help with homeostasis, your heart rate and breathing rate, which I'm going to cover, but it's also going to relay information. That is its big job. When I talk about relaying information, it's relaying sensory and motor neurons. So sensory neurons are going to travel up, motor neurons are going to travel down. So remember that your precentral gyrus, this is where motor travels from, is the top. Motor neurons are going to travel down. That is what I mean by relay information. So we'll talk about the midbrain first. Your midbrain is going to relay sensory neurons, blue, to the thalamus as they travel up the brainstem. They're going to relay motor neurons from the precentral gyri, from the frontal lobe, down the brainstem. So we relay sensory information up, and we relay motor neurons down. That's all we're going to say on the midbrain. It's a relay for sensory neurons, and it's a relay information from motor neurons. All right, now the pons. One thing that we talk about for the pons is the pons is closely associated with the cerebellum. Right behind the pons is the cerebellum. So it's going to relay information to the medulla oblongata down from the cerebrum. I'm going to put down to the medulla oblongata from the cerebrum. But it also is going to relay information from the cerebrum to the cerebellum. So the pons, when we talked about the cerebrum helps us with complex motor movements. So the pons is directly contacted with the cerebrum or cerebellum. So this is going to transmit impulses or information from the cerebrum to the cerebellum. The pons is in the middle. So that's the pons. It relays information up and down just like the midbrain. Now, the medulla oblongata is the most important, and I'm going to put a bunch of stars right here, and we're going to turn this over and talk specifically about the medulla oblongata. We will not have room to cover the medulla oblongata. The medulla oblongata is the most important structure of the brainstem. All right, first of all, if you damage the medulla oblongata, most often it'll result in death. That's why it's the most important structure. Now, I'm going to give you the reasons. The medulla oblongata has 3 centers. The first center is called the cardiac center. This is going to control your heart rate. So if you damage this, you can't control your heart rate, death. The second thing is your respiratory center. Your respiratory center is going to control your breathing. When we talk about breathing, it's going to be your rhythm, so how fast you breathe, rhythm and rate, and how deep you breathe. If you're not breathing in deep enough, you could die. Death. So your heart rate doesn't work right. Your breathing is all messed up if you damage this. And then the next center that it controls is it controls the vasomotor center. Now, the word vaso means blood vessel, and motor is muscle control. So this is going to control contraction or relaxation of smooth muscles located in the walls of blood vessels. So the motor represents smooth muscles. We always learn motor neurons go to muscles. So when we talk about the vasomotor center, it controls vasodilation. This is when your smooth muscle relaxes and the vessels get really big. So the muscles in your blood vessels relax, so your blood vessel gets really large. That's vasodilation. If you say vasoconstriction, the smooth muscle is going to contract and the blood vessel gets small. The smooth muscle contracts. And then the diameter of the blood vessel is very, very tiny. So, the medulla oblongata has 3 centers, and this is the most important center because you've got the cardiac center, the respiratory center, and your vasomotor center. When you see vaso, it means vessel, and motor means muscles. Well, smooth muscles, because we know smooth muscles are located in our blood vessels.